Let's discuss what is Finder's algorithm, how it works, what is the purpose of it. Before getting into the concept, we should understand certain terminologies which will be helpful for you to understand this Finder's algorithm. So first one is concept learning. Concept learning is nothing but already a concept has been provided to the machine. So the information have been provided to the machine, and from that concept the machine tries to learn something. So that learned thing will help the machine to identify or predict or classify whatever input you are providing. So it may be correctly classified or it may wrongly classify. That depends on the learnings which it has been made. So concept learning is the most important thing in machine learning. As we already discussed, supervised learning, we will be providing the information with the labeled data. The outcome will be provided, and we will be feeding all the feature information for that particular outcome. So that is nothing but a concept that will be provided to the machine, and machine will learn from it. And whenever you are giving a new input, the machine will correctly predict what it is based on the learnings. So supervised learning is one kind of concept learning. And the next terminology is hypothesis. Hypothesis is basically an explanation for something. So here it indicates an assumption. If you are attending an end semester examination for a neural network and machine learning subject, in that case I will be asking you after your exam what will be your score. So at that time you will assume something and you will say that you will be getting A plus or O grade. So that is nothing but a hypothesis. So that may be positive or may be negative once the results been published. So we have to evaluate whether it went wrong or it is a positive one. So we have two categories of hypothesis. First one is general hypothesis and second one is specific hypothesis. So general hypothesis is nothing but it explores the relationships between different variables which you have in your data set. And specific hypothesis is in-depth details about each and every attribute, and the values for that attribute will be provided. That is the specific hypothesis. So I have given you certain examples here. So the first example basically describes the concept learning. Here we have given the concept as different shapes. The same feature, which are all the shapes having the same feature, are grouped into same clusters, and odd one out is actually eliminated from the group. So we are already providing the concept to the machine. From that it learns and it will eliminate which are all the shapes that doesn't matches with that particular cluster. And the second example is nothing but a burger. So if you are entering the Burger King and if you want to order a burger for your lunch, so how you will make that order to the salesman? Simply if you go and say that you order a burger, so if that is the case, then it is a general hypothesis. You will be accepting whatever the type of the, irrespective of the type of the burger, you are accepting that. And so the third example is, it is specification. So if you want a cheese chicken burger, then you have to specify all the requirements in depth about what it is and what is your requirement. So if you say that, then it comes into specific hypothesis. If you're just ordering a burger, then it is nothing but a general hypothesis. The objective of a Finder's algorithm is, if you're providing a machine n number of examples to train itself and to learn from that, right, the machine first looks at which attribute is actually contributing to the outcome. See, if you want to identify an apple from the basket, and the basket consists of so many fruits, in that case you are going to identify an apple from the basket. If that is the expectation, then how the machine will train itself? So first you have to give all the features of the fruits which have been placed in the basket. So it consists of n number of examples. It may be a positive example or it may be a negative example. You have to give it to the machine. So once it's been obtained, the machine will try to learn from each and every examples or each and every sample which you have given to the machine. So at last it will find which feature is actually contributing a lot to predict the given outcome properly. So if Apple, we will take three features. One is color, the second feature is texture, the third one is shape. So it will look into all these three features in all the samples. So if I have a green apple or red apple over there, so first the color, when it checks with each and every example, if the first example which you have given for training the model is green apple, then it will check with the color. So color is green and it will learn from that. If the color is green, then it should be an apple, because we have specified that if the color is green and texture is light spotted and the shape of the apple little curved with a cylindrical shape, top and bottom with a bend, if this is the information, if these are all the features, then it should be categorized as apple. So if we have given this information to the machine will learn from that. From the second sample, if we are giving the color as red, so in first sample we have given color as green because it's a green apple, and in second we have given a red. So at that time it will learn that the color may be different, but the label outcome is apple, so it is categorized. So irrespective of the color, it have to check with some other features which strongly contribute to identify rightly that the given object is apple or not. So in the second feature we have given a shape. So shape remains the same for apple even if it is a green apple or a red apple. And third feature is a texture. So in the second sample the texture is heavily spotted, and in the first example the texture of the green apple is lightly spotted, so that also differs. So the machine learns from this and it comes to a conclusion that only the feature of the apple named shape doesn't change. It remains unchanged from start till end for all the examples, and while it checks with the other features which contribute to apple, it differs. So irrespective of all other features, first if you are asking the machine to identify an apple, it will go and check with the shape first. If the shape is matches with the learned concept, then it will identify that as an apple. So basically finders algorithm is going to give you a conclusion of the hypothesis and assumption, right, in which which feature is heavily contributing for identifying or predicting the given input. That is the job of finders algorithm. So maximally specific hypothesis based on labeled training data that should be identified at the end of finders algorithm. So these are all the symbols which is used in finders algorithm. This is a pi symbol which specifies empty set. It is most specific hypothesis. Finders algorithm basically starts from most specific hypothesis and then ends with the general hypothesis. So here the null value can be replaced by any value. It may be an S value or it may be a no value as per our example which we have discussed for identifying the apple. And question mark is a symbol that indicates that you don't care the value, whatever the value is, you will not care about what it is. So just we have discussed in the example that the feature named texture and color, right, that differs. So we don't care about those features. So that will be given as question mark. It is don't care or unknown attribute value. And we have two different examples here. It is positive example and negative example. If in the given examples which is used for training the data, training the machine, if the example results in categorizing the apple as S, it is apple, then it comes into positive example. And if it is categorized as it is not an apple, then it comes into negative example. So here the target class is nothing but it indicates the final label outcome of each and every example. And H is hypothesis. Hypothesis is nothing but an assumption. So this is a process flow. Initially you have to make the initial hypothesis. As I already told you that initial hypothesis consists of most specific hypothesis. So it is an empty set. We doesn't have any idea about the value of the features before start learning the content, the concept. So initially we are having null knowledge about it. So all the feature is going to initialize with the value pi, that is empty set. And after that you have to identify a positive training example, because Finder's algorithm focus only on positive training example, because you are going to identify whether the given object is an apple or not. So you are going to identify whether it is apple. If not, obviously it will enter into not an apple case. So positive examples alone will be taken into consideration for learning. So it will ignore the negative training example while it involves in the training process. So and then you have to check for each and every attribute, that is feature value, after considering the positive training example. So if the attribute value matches with the hypothesis value already initially we are having null value. After each and every example learning, started the learning process, the hypothesis value for each and every feature varies. So that value will be matched with the attribute value, and we are checking whether the result is yes or no, if whether it is matches or it is not match. If it matches, then obviously you have to move out to the next attribute and check whether that attribute is going to strongly contribute for the prediction. Here if it matches, then it is nothing but it is an indication that it remains unchanged, so it is strongly contributing for the prediction of a given object. So if it is no, you have to replace it with the value question mark, because question mark is nothing but don't care value. It may be any value, so it is not much contributing because it keeps on changing for the same object in different examples. So once replaced, again we will go and check with the attributes. This iteration will end only when you reach the end of the attributes. Once you have completed all the attributes in your hypothesis, then it will move to the next learning process. So here is an example for Finder's algorithm. The given rule is we want to identify the combination of symptoms that reliably indicate the presence of a fever. So you have to identify which symptom maximally contributing for predicting whether it is a fever or not. So the training data consists of 3 different features: headache, muscle aches, chills. So these are all the 3 features which contributes for identifying whether the particular patient is suffering from fever or not. We have given 5 different patients data in order to learn the model. So let's see how the machine will learn from this data using Finder's algorithm. So first, initially we have to consider the hypothesis as null value. Basically we have 3 different features: headache, muscle aches and chills. So here I am making it as null because initially I don't have any knowledge about it. I haven't even started the learning process. The machine is not having any prior knowledge about it, so it is null. So this is most specific feature. We are starting from most specific hypothesis because this null will match with either S value or no value. Anything may be the value of headache, muscle ache and chill. So it is considered as the most specific hypothesis. Finder's algorithm will start from most specific hypothesis and end with the most general hypothesis. So the first case, the first patient, as per our record, The hypothesis is having the value S, headache as S, muscle aches as S, and chills value as S. If all these three features value contribute to S, then it is nothing but it indicates that the patient is suffering from fever, because the label which is given for fever is S. So this is hypothesis 1, which the machine learned from the first positive example. So the patient 1 data is actually a positive example because the value for the fever feature is S here. And the second positive example, this hypothesis H2 contributes that the fever as yes. So it is a positive example. Then the machine decides that if it is a positive example, then it have to learn from this. So here the headache is no. The headache for patient 2 is no, hence it is replaced with a question mark. In patient 1 example, the headache value is S, and in patient 2 example, the headache value is no. So here you have to note that the headache value changes, but still the fever for patient 2 is also contribute to S. So irrespective of headache, the patient is suffering from fever. The headache, some patient have the headache, some patient may not have the headache. So we cannot consider this headache feature as a strong maximal contribution or contributing feature to for the prediction. Hence we are replacing it with question mark. And then while we check the muscle ache value for patient 2, it is S. So it matches with the previous hypothesis H1. So we are retaining it. And while I check chills, this also matches with the attribute H1 attribute value S. So we are retaining it. And while I see third positive example, the third in the training sample, the H3 headache, already we have changed this headache to question mark, so we don't care about the value of headache feature. So it is question mark. So next we'll be seeing muscle aches. So muscle aches here for patient 3 it is no. So when it is considered as no, we have to check with the previous hypothesis value. We are in H3, so we have to check this with the H2 value. So for patient 3, muscle ache is no. The value of muscle ache attribute is no. You have to compare this muscle ache value with the previous hypothesis. It is yes. So this is contrasting. So this is not contributing to the prediction of a fever. So that will be converted into a don't care value. So this headache and muscle ache is not contributing to the prediction of a fever because it changes over the training process of different patient data set. So next coming to the point, chill feature, when this patient 3 is having chill attribute value as S, you have to compare this with the hypothesis 2 value, the previous hypothesis value, chill as S. Here it matches, so it keeps on retaining the same. So now while I check with the fourth and fifth example, patient example, it is a negative example, so we'll be ignoring it. The finders algorithm basically ignores a negative sample, negative example which is given in the training data. So based on the three positive examples as per the records given in the training data, so this chill is retaining its value same from start till end. So we are concluding that chill feature contributes maximum for the prediction of a fever, because each and every patient is having chillness, right, irrespective of whether they are having a muscle ache or headache. So this contributes maximum to predict the fever. Here is the final hypothesis. We have concluded that the final hypothesis headache is don't care value, muscle aches is don't care value, and chill is the only value of the only attribute value which contributes for the prediction of fever as label S. The finders algorithm finally provided the outcome. It comes up with the learning that The presence of chills strongly suggests the presence of a fever for the patient. So next time while you are making the machine to identify whether a patient is suffering from fever or not, if you are giving a data to it, input data, then first it will check with the chill factor value, the feature value of a chill. So if chill is having S, then obviously it will give you that the patient is suffering from fever, irrespective of headache or muscle ache value, because those two are considered as a don't care value in Fineless algorithm final hypothesis. So these are all some limitations. So the major limitation is we are focusing only on one side, that is positive example, training the model only with the help of considering the positive examples, and we are ignoring the negative examples. So we are focusing on concluding only one hypothesis, a single hypothesis, which strongly contributes to the prediction. But this is not, this may mislead you in the later case, if your data set is too large or if it consists of various features. And backtracking is not possible here in the Finder's algorithm. So it is not possible for us to improve the outcome by getting back to the hypothesis learning model to make the best possible changes in the intermediate stages. So these are all some limitations which is involved in Finder's algorithm, and to enhance this, to overcome the limitation of Finder's algorithm, we'll be discussing the candidate elimination algorithm in the next session. Thank you.